right, this is our last section of notes before the first major test. So we've got the lesson P1. This is actually going to be the first section of your prerequisite test, which is on just real numbers, but it really gets into that the interval notation that I had talked about on one of the first days. So this is just how we're going to formalize it. And it just says that our interval notation is really careful about how we are bounding or not bounding our intervals. So a closed interval is considered, I know that's really hard to see, but you should be able to see it on your notes. This is the number A to B. Now, a square bracket simply just means, I would write this down, square bracket means included. Parentheses means not included. Okay, so that's really all you need to know. So the way this works is if we're going from A to B, both of them are square brackets, that means we're including the endpoints A and B. And we can see that on our graph that if we did this, you might also see that as a closed point. Whereas down here, using parentheses from A to B means we're not including the endpoint, and oftentimes we have that as an open circle on our intervals. So it's always from the left to the right, lower to higher number. And we can do half open, half closed intervals, so this would be a closed point here and an open dot here. This would be an open dot and a closed, so you might get used to seeing that. So these are on bounded intervals. That means we're strictly going from one number to another number. And the second graph just shows, or the second picture there just shows what happens if we're dealing with infinity. Well, we can have a closed infinite interval where we go from the definite number A, and then it just goes on for forever until infinity. That's just x is greater than a. These all mean the same exact thing. Here, parenthesis, again, means not included. And notice that we always put parentheses around our positive or negative infinities. And that's strictly because you can't physically put in positive or negative infinity, or we can't use that as a number. So if it's not included as a number, that just means parentheses. That's all. So to try these out, we have a couple examples down here. Converting between intervals and inequalities. Here I'm going from -6 to +3. Well, -6 is included because it's a bracket, so I'm going to do a closed point there. +3 is open, and we want everything in between. Voila. That's it. Here I have, convert interval notation to inequality notation, or vice versa, and we're all going to graph that. So I apologize, I did not actually write that in interval notation. That is, we're going from -6. We can always do it this way. So left number less than x less than right number. However, I need to make one adjustment. Since this is included, I make that a less than or equal to. So that's the only difference here. Now you can write this as negative infinity is less than x is less than -1. Notice both of those are parentheses, so I don't need an equality here. But can x actually ever be less than negative infinity? No, that's absurd, can't happen. So we don't really, I don't want to write that. It's redundant. So this is what you're left with. X is less than -1. Well, what's that look like on a number line? Go ahead and graph that. Open hole at -1. And to the left. Lastly, we want everything from -2 is less than x to +3. Well, this is inequality notation, so turn that into interval notation. I've got to go -2 and 3 are my endpoints, and I do want both of the endpoints. So what sign am I going to use there? Yeah, parentheses. That's what it's going to look like. Now, what does that look like on a graph? Both of those are filled in, and we want everything in between. Boom, done. So that's all you really need to know about interval notation, and hopefully that clarifies things up from when we were using it before. Now the last thing, I do want you to try example 2 on your own. Take a moment and do that yourself. I will write these answers up here silently, and you can check your work when you're done. So when we multiply things with exponents, we add the exponents. That's the gist of that. When we divide things with exponents, we subtract. So hopefully you subtract it again. That's always top minus bottom. 2 minus -1 is 3. -2 minus 3 is -5. But never, forever never, leave an answer with a negative exponent. Move its position, change its sign. So this is the same as u to the 3rd over v to the 5th. Lastly, we can technically flip this as 2 to the 3rd over x to the 6th. So again, the negative, you can flip your fraction there. That's the moving part and make it positive. But then it has to go to both of those. So 2 to the 3rd is 8. X to the 6th is just x to the 6th. And that's it for P1, really. If you have questions on it, please let me know. But then have fun reviewing.